So in this section, one of my favorite topics actually is stream erosion. So if any of you have been in upstate New York, Pennsylvania, anywhere there's a mountainous area and been near a river or a stream, pretty much all this is observable. So one of the reasons why I really like this topic. So we're going to talk about stream velocity. We're going to talk about, remember, there's all erosion. So we're talking about how the stream is going to move rocks downstream, move rocks with the water. So velocity is speed. The speed of the stream is dependent on some things. Number one, the gradient. Gradient should be a review for us at this point. We're talking about how steep the landscape is. So obviously, the steeper it is, the faster the water is going to go. Stream discharge means how much water is in the stream at that time. The more water in the stream, the faster it's going to go. And the shape of the river. If you have a straight river with no turns in it, it's going to go much, much faster than if you have the curves. The curves will actually slow down the speed of the water. So we're going to talk about how does the stream velocity affect the carrying power. And right here in our handy dandy reference table is a chart to show you that. I'm going to be giving you a worksheet tomorrow to help work on this, but this chart really helps to show the speed and the speed of the stream and the size of the particle it will carry. So we've seen this before because here on the side is the name of the particle size, the name of the particle, and the size of it. So we talked about it when we did porosity and permeability. We referenced this chart. Clay is the smallest, silt, then sand, pebbles are larger, cobbles, and then boulders are the largest. Now at this point, on the bottom is the velocity of the stream. So over here, really, really slow stream, almost still, okay, not really carrying anything until you get to this point. And then you're starting to carry. The second the water moves, you pretty much are carrying clay in it because a lot of times the clay will end up being dissolved in the water or really, really light. Then as the speed increases, you will see the size of the particle increases. So we have a direct relationship. And then look, so pebbles are actually really big. You're from 0.2 all the way up to 6.4 centimeters. So a pebble is very, very large. And you need speeds starting at 10 centimeters per second, going all the way up to, now look at how I'm reading this, okay, that this line and this line meet. So you're going all the way up to about 200 centimeters per second just to carry a pebble. And then, of course, you have much, much higher speeds to carry the boulders, and then it gets to a point where you can't even carry the boulder. So some of the ways that a stream will carry the material, rolling on the bottom, larger, heavier ones kind of roll along the bottom, all right, much, much slower. Suspension is like those clay particles. If you were to step into a lake and you step in and all of a sudden you see that mud come up around your foot, it'll stay there for a while. That's in suspension. And then the finer particles work like that. And then the stuff that dissolves in the water will move anywhere the water does. That's because it's in solution. It's dissolved in there, almost like when you go to the ocean and it's salt water. So that's what these are here. Streams can carry in solution, anything dissolved. Suspension, as we just said, carried with the flow. And over here, saltation, larger ones will bounce, and then the much, much larger ones will roll along the bottom.